Prove algebraically that the product of two odd numbers is always an odd number. Okay, so first of all, let's get two expressions, because we have to do this algebraically. Let's get two expressions for odd numbers. Remember that an even number can always be written as 2 times something, 2 times an integer. So an odd number could be 2 times an integer plus 1. So that's how I'm going to represent one of the odd numbers. I'll call it 2n plus 1. And the other odd number, I'll represent that by saying 2 times a different integer, m plus 1. So this is an odd number because it's 2 times something plus 1. So this is an even number. Plus 1 will make it an odd number. And this is also an odd number because again it's 2 times a number, a different number to this one, which means this is a different odd number to this one. I know these look very similar because they're both odd numbers, but they represent 2 different odd numbers because this is a different number to this one. So again, yeah, 2 times an integer will make this an even number. Adding 1 to that will make an odd number. So this is odd, and I want to see the product of these. So all of this times all of that. Okay, so let's expand these brackets out. So I've got 2n times 2m. So the 2 times the 2 would make 4. N times the m would be n, m. Or mn if you prefer, if you're bothered about your alphabetical order. Right, we've now got 2n times 1, which is 2n. We've now got 1 times 2m, which is 2m. And then we've finally got 1 times 1, which is 1. So there we go. This is an expression for the product of those two odd numbers. And I need to now show that this is always an odd number itself. And remember what I said, an odd number can always be represented as 2 times something, because we know that's going to be even, plus 1. So I want to make that look like that, which I can do because all of these terms at the front have all got a common factor of 2. So if I factorise 2 outside of these 3 terms here, this would be a 2nm plus n plus the m plus 1. So we can see now that 2 times all of this, so this is going to be an even number. So when I add 1, it makes it odd. And there we go. We've shown that the product of 2 odd numbers gives this, which is actually also odd.